Our next section is on families of functions. If you understand that all functions come from the same basic families, it makes understanding what their graphs are supposed to look like and what they're supposed to mean a whole lot more better. Yeah. So we're going to answer the question, how does understanding function families help us interpret data? So we're going to understand the relationships between the parent function and transformations that change that function, and then analyze some transformations of functions. Our first vocab word is a parent function. This is the simplest form in a set of functions that form a family. So if we had y equals 2x and y equals 2x plus 3, y equals 2x would be our parent function because that's the simplest form. So each function of the family is a transformation of the parent function. And a translation is just a transformation that shifts horizontally, vertically, and does not change the shape or the orientation. A reflection either flips it across the x-axis or the y-axis, so we have two different kinds of flips. A vertical stretch just multiplies that function by a factor that's greater than 1, and a compression multiplies it by a factor that's between 0 and 1. So stretch just makes it bigger, compression makes it smaller. So first we're going to talk about vertical translations. So how are the functions y equals x minus 2 related, and how are their graphs related? So which one of these would be our parent function? Which one is in the most simplest form? Y equals x would be our parent function. So we're going to go ahead and graph these both on the same number line. Alright, so first I'm going to start with that y equals x. As you can tell, that's a direct variation equation, so it's going to go through 0, 0. And our slope is 1. It's positive, so it's just going to be like this. This is y equals x. Okay, now for y equals x minus 2, I'm going to go ahead and make a set of values. So x, y, I'm just going to pick numbers. So 0. 0 minus 2 is negative 2. 1 minus 2 is negative 1. 2 minus 2 is 0. I'm going to go ahead and plot these. Oops, this is 0, negative 2, 1, negative 1, 2, 0. As you can tell, this also has a positive slope of 1. What do you notice about the graph of this? This is y equals x minus 2. Do these lines have the same slope? Yes, they're both understood to have a slope of 1, so they are parallel lines. What's the difference between this one and this one? Well, this one moved down 2. Okay, so let's see this one. What's the graph of y equals x squared minus 1 translated up 5 units? So we're going to go ahead and graph y equals x squared minus 1. So let's see, we have to make some x, y values. Does anybody know what this x squared is going to make? Well, if not, we're going to find out. Okay, so let's plug in 0. 0 squared is 0, minus 1 is negative 1. 1 squared is 1, minus 1 is 0. Negative 1 squared is 1, minus 1 is 0. So 0, negative 1, 1, 0, negative 1, 0. Let's pick another point, like 2, just so we can make sure we have a good idea of the shape. 2 squared is 4, 4 minus 1 is 3. We can reflect that across. Okay, so it makes a parabola. Now it says translated up 5 units. So what do you think we're going to do? Just go up 5. 1, 2, 3, 4, 5. Right here. And it's going to follow that same exact curve, just going to be up. So I want you to think about this one. How are the functions of y equals 2x and y equals 2x minus 3 related? So then how would their graphs be related? Well, obviously they have the same parent function, y equals 2x. This minus 3 is the only difference. So what do you think is going to happen when we add the minus 3 on the bottom? It's going to go down 3 units. Okay, we also have horizontal translations. These are going to be the ones that move them left and right. So I have a picture here, there we go, of airplane altitude. So it shows the takeoff, the staying in the air, and the landing. So it's a flight that looks like it's about 3 hours long. So it says, if the airplane leaves 2 hours late, what function represents this transformation? Well, if we leave 2 hours later, obviously we're going to have a 2 hour later start, so we're going to go ahead and just move it 2 units to the right. But when we write it, even though we're moving to the right in a positive direction, we're moving the whole function, so it's going to be a negative 2. So this one is just opposite. So what if the plane leaves 30 minutes early? What would that function look like? Well, we have 30 minutes, that's a half an hour, and that's leaving early, right? So we're going to go in a positive direction, so it's going to be the opposite. So it would be f of x plus 1/2. And when we do reflections, we can reflect across either axis. When you reflect across the y-axis, the x values change signs, but the y values stay the same. And you reflect across the x-axis, the x values stay the same, and the y values change. So they do opposites. So if you're going to reflect across the y-axis, you do the opposite of all the x. Whereas if you reflect across the x-axis, you do the opposite of everything. So let's take a look at these. So let g of x be the reflection of f of x equals 3x plus 3 across the y-axis. So what's the general function rule for g of x? So do you remember when we reflect across the y-axis, we're going to change just our x values. So g of x equals 3 times negative x plus 3. So you just write that as negative 3x plus 3. So you see only the x value changes, just the value of x. But what if we were going to take that same function and reflect it across the x-axis? Well, when we reflect across the x-axis, we change the entire function itself. So h of x is actually negative 3x plus negative 3. So we change all the signs. So it's now negative 3x minus 3. So you see this number changes each time. So stretching and compressing, basically it's just multiplying by some constant to begin with. So if I give you these values, so I have x are my inputs, f of x are my outputs, so my y's. So if we wanted to find g of x is 3 f of x, all we would do is we would take all of our f of x values, all of these values on the bottom, and multiply them by 3 in order to get g of x. So my g of x would be 2 times 3, 2 times 3, negative 3 times 3, 1 times 3, and negative 2 times 3. So g of x is 6, 6, negative 9, 3, negative 6. Not too complicated. Okay, so go ahead and use those same numbers and find the transformation h of x, which is 1/3 f of x. I got h of x to be 2/3 2/3, -1, 1/3, -2/3. So you just multiply everything times 1/3. Okay, here's just a summary to help you understand what's happening with each thing. So if we're going to translate up and down, up is going to be positive, down is going to be negative, and this is going to be outside our x value. So we're not going to have it in parentheses. If it were in parentheses, we move it left and right. And remember, it's opposite. So right has a negative, left has a positive. And then stretches and compressions are just multiplied by some constant in front. And then reflect across the y-axis makes it the whole function negative, or the x-axis, and reflect across the y-axis just makes each x value itself be negative, not the whole thing. So let's combine some transformations. So we have g of x is the graph of f of x. So our parent function is 4x. We're going to compress it vertically by 1/2 and then reflect it across the y-axis. So the first thing we're going to do is that compression. So we'll just take 1/2 of 4x. Well, 1/2 of 4x is 2x. Now we need to reflect that across the y-axis. And we reflect across the y-axis, which values do we change? All of them or just the x value? We change just the x value. Well, in this one, there's x is the only value, so you're going to change the whole thing. But remember why we change only the x values. So we're going to reflect it and make it -2x. So our rule for g of x, for our parent function 4x, compressed by 1/2 and reflected across the y-axis, makes g of x be -2x. So then you can go ahead and graph these and see how they compare to each other. Okay, so go ahead and graph these three functions and then compare how the resulting g of x and h of x are, and then talk about those with your partner. And your homework for tonight is lesson 2-6 and to watch video 2-7.